So by far we have covered your three major subtopics in section M, that is food chemistry and nutrition, food microbiology, and food products processing. Now before we move on to the fourth and the most technical section of this area, that is food engineering, I would like to give you a few more tips on choosing your reference books. Now, related to food technology and food industry, there are several books available on the internet, freely downloadable. Some of them hard copies. You can purchase hard copies of them, and they might not even be very expensive. Around 150 to 300 bucks, you should be able to avail them. So these books you can definitely refer for yourself. Uh, if you find them simpler enough than the other reference books which we have been talking about. But one piece of advice over here to you will be that do not opt for objective books in the first place. There are lots and lots of objective based question books available on these topics, so they might help you at a later on stage maybe, but in the first place it is always a good idea to go for a proper reference book rather than objective based books. This was one important thing which I wanted to share, because when I was searching for several books to suggest you on the given topics, I came across many of these books which might look very attractive in the start but would not be a good choice to select, and would not take your preparation in a very positive approach as it should be. Alright, so let's move on to the next and the last subtopic of this section, that is food engineering. Now, food engineering is a very technical topic. Unlike the previous topics which we have been dealing by far, there have been quite a few technical aspects which we have touched, but this will relate majorly to the physical implications of mass, energy, momentum, transfers, thermal operations, and topics like that. So, if you have had food technology as a part of your subject or as one of the applied components theory papers, you might not have covered these topics in a lot of details. So this is one of the topic where I would suggest you to pick up in the end. And even while you're dealing with food technology, please study them study them keeping in mind these topics. So if you remember, in the first place I have been talking about being thorough with your syllabus. Being thorough with your syllabus is going to help you to link each and every topic to every other aspect of what you are trying to read and understand. That gives you an extensive approach to reading. Now, mass energy balance, mass transfer, and other technical topics which are included in this section will definitely have a reference to all the food processes of different products which you have studied above. So, before you start with food technology or your section M, please read through this last part or last subsection of this particular section. So, once you are thorough with the topics involved in food engineering, after that you can relate these topics to whenever you are studying any other process. So when you finally arrive on getting into the depth of these things, you will already have a good background preparation. Alright, so let us begin. Now there are two sections over here. One is mass energy balance and the other one is related to operations. Now, I would suggest that you first pick up on the operations section, which seemingly is much more easier. So, you have three types of operation procedures to be dealt with. The first one is mechanical operation, then you have thermal operations, and then you have mass transfer operations. In mechanical operation, you will be dealing with energy requirement and rate of operations involved in size reduction of solids. Now, what does this mean? Now, in your food industry, you might have read in any of the above topics before that particle size or food size or the amount of particulate optimum size which is required as an end product property is very, very essential. So while you are undergoing several procedures such as filling or canning or mixing, so all of this will have an impact on the final particle size. Also, some products might not require, or it would be inappropriate or an undesirable quality to have solid retention in them. So mechanical operations have to be operated in a way such that their energy requirement has to be perfectly suitable in a way that it gives you the required size of your end particles. Then you have high pressure homogenization, filtration, centrifugation, there is settling, sieving, flow through porous bed, agitation of liquid, solid-solid mixing, and single screw extrusion. Now, what are all of these things? If you guys have studied the topics above, there have been several products. Well, you make the flow sheets of how each product is being formed, whether it is through fermentation, it's some dairy product or some animal origin. So there will be some or the other procedure where you will encounter these words. So all of these are part of your mechanical operation which are conducted at various levels and at different degrees depending upon your product. So this relates to your mechanical operation. Now, as we know that no machine can operate without energy, so definitely this is going to link you to the thermal operation side. Now, thermal operations will be dealing with the energy requirement and the rate of operations involved in process time. So your entire energy input for a given batch process or a continuous process will be evaluated, and the energy involved in continuous sterilization, it could be involved in evaporation of liquids, it could be in hot air drying of solids, spray and freeze drying, freezing, crystallization. Although in the end you can see most of these things are diverting you towards the last part of your product formation procedure, but however the evaluation will be done right from the start of the batch, or if it's continuous then it would be done according to the continuous sterilization. For these two topics I would suggest two important books, or rather three important books which I came across. Now one of them was Introduction to Food Engineering, that is by R.P. Singh and D.R. Heldman. And another book was Fundamentals of Food Engineering by D.G. Rao. A third book is Food Technology by Neil Morris. Now all of these three books have a good reference material for the topics which we have been talking about over here. Students might get confused with these things and might refer materials which would be available in your compiled books, which you might be referring for gate preparation and all of that. But however, it is a request to those students who are dealing with these topics in the first place to please go to your library, check out if you have any of these books available or some book which is related to the topics which I have mentioned, and first refer through the proper procedure in those books. And then later on for your revision you can make quick notes, you can highlight topics which you would want to revise, and in the end when you give it a revision at the second and third time, it is at that point of time you will actually have a good grasp. So it is very much natural that students tend to forget, students tend not to understand these technical aspects, engineering aspects, which not everybody might have been comfortable with. So it is a request that you refer proper reference books, make your own small notes, keep marking topics which you are not comfortable with, and then go ahead, for a second and third time revision, and I assure you that by the third or fourth time you will definitely have a very good grasp on all of these subject topics. So this is how we can approach to this particular subtopic over here. Now, in continuation, you have mass transfer operations. Now, mass transfer operation is definitely dealing with the properties of air, water, vapor mixture, humidification, dehumidification operations. So, this is going to be a connection between your mechanical and thermal operation. So, there are two books I would like to refer in this section. That is Introduction to Food Process Engineering. This is by P.G. Smith. And there is another book by the same title, but the author is Barsosa Canosa. That is Introduction to Food Process Engineering by Barsosa Canosa. A third book in this section is Elements of Food Engineering by Watson and Harper. So, if not all of them, at least one of them would be available in the library which you are referring to for your reference books. So please make sure that you refer proper books for the guidance on these topics, as they are very, very important to understand, and only then you will be able to approach the analytical based questions on these topics. So this was the operation related procedure what I wanted to talk about. Now the next section, that is mass energy balance, which involves momentum transfer, heat transfer and mass transfer. So there are topics involving flow rate, pressure drop relations for Newtonian fluids through pipe. Then you have to list down characteristics of non-Newtonian fluids. Then you have to talk about generalized viscosity coefficient. There is mention of Reynolds number. There is flow of compressible fluid, flow measurement, pumps and compressors. This falls under the section momentum transfer. Now, as you can see, the topics are very much core into the mechanical engineering aspect. I would suggest that you prepare a small notebook, and as and how you are studying, start making flowcharts, tables for them. For example, the first thing you can do over here is study the Newtonian fluid and non-Newtonian fluid. Make a side-by-side comparative chart analysis for both of the fluid, that is Newtonian and non-Newtonian. Then you can go ahead and talk about the flow rate and pressure drop relationship, or you can even mention this in your comparative analysis, that is the similarities and differences between both of the fluids. Then you can go ahead further, you can talk about their generalized viscosity coefficient. Then you can make a note, a short note on Reynolds number. You can go ahead further, draw diagrams of pumps, compressors, draw freehand diagrams, keep labeling them, and that is how you will get to know the differences between the various options available in these categories. Like many types of pumps and compressors will be there, which you might find confusing in the first place. So to avoid that kind of a confusion, it is suggested that you start drawing these diagrams, labeling them, and then you will automatically understand the differences in their operation and why a particular type of pump or compressor is chosen for a given procedure. So this is one of the things to be referred over here. The next is heat transfer. Now, heat transfer has been mentioned in your school books as well. So I'm sure some of you will be comfortable in dealing with topics that is such as conduction, convection, radiation, and there is boiling, condensation. So these topics you can easily go through, and what you need to additionally learn over here is their principles. You have to learn any related formulae. You keep writing the formulae, keep practicing them again and again. And going ahead, you have to study about the unsteady state heat transfer in simple geometry. So this is read as it is from your syllabus. Then you have NTU, effectiveness relationship of co-current and counter-current double pipe heat exchanger. Now, since this much is mentioned in your syllabus, I would suggest that you stick to these topics only. There will be a lot of aspects involved in heat transfer and subjects or sections related to this, but for your examination purpose, for those students who have not studied these topics before, it is a request that you maintain the heat transfer as much as to the given syllabus. Finally, you have mass transfer. Now, mass transfer involves molecular diffusion. There is Fick's law. There is steady state mass transfer. There is convective mass transfer. And finally, you have permeability of films and laminates. So, for all of these topics, there is only one book that I would suggest. The book title is Fundamentals of Momentum, Heat and Mass Transfer. Now, the authors are Welty Rohrer and Foster, and you have this available by Wiley Publication. So, even if you refer to all three of these topics through this one book, I think it should suffice your preparation for GATE examination in this section. Other than that, if you have access to better libraries or online content, you will be able to find more amount of data. One advice for your food engineering related section over here is that you should refer to video lectures or visuals of how these processes are being conducted. There are many beautiful freely available video content which will demonstrate, which will animate the working and principle of these different topics, that is momentum transfer, heat transfer, and even your operation related procedures. So it will be a good idea to refer to these topics through video lectures after giving a first read through your reference book. So the process for following this study would be: go to a reference book, study the topic, make your own notes. In the second place, go and visit some site which is offering animated visual or demonstration of the principle and working of these mass and energy balance related topics. And then in the third place, you once again will opt for a second read to your reference book, and that is when you will feel confident about the understanding and working of these topics. So with this, I guess we cover your food technology related section for your GATE examination. I wish you all the very best for your preparation. Thank you.